All right, so it says a blind taste test will be conducted with 9 volunteers to determine whether people can taste the difference between bottled water and tap water. Each participant will taste the water from 2 different glasses and then identify which glass he or she thinks contains the tap water. Assuming that people cannot taste a difference between bottled water and tap water, what is the probability that at least 8 of the 9 participants will correctly identify the tap water? Okay, so probability that at least 8 of them correctly identify it out of 9 of them. So if we're gonna assume that it's just luck, this is essentially they basically have a 50-50 chance of guessing correctly. So this is an example of a binomial random variable. So we essentially want to find the probability that the number of successes is at least 8. So depending on the notation in your textbook, maybe k. The probability that k is greater than or equal to 8. So number of trials is 9. Probability of success on each trial is 0.5, and k is 8. So NPK. So the probability that k is greater than or equal to 8, that's the same as 1 minus the probability that k is less than or equal to 7. That's going to be equal to the probability that k is greater than or equal to 8. Now, the reason I'm doing it this way is because your calculator can't calculate the probability when you're talking about greater. It can do it for less than though. So in your calculator, you're going to do 1 minus, and you're going to go to binomial CDF. Binomial community density function. And we have this calculator, its syntax is NPK. So N is 9, comma, P is 0.5, and K will be 7. So NPK, and you'll get about 0.019. So the answer is B. Number 26, a school administrator is interested in estimating the proportion of students in the district participating in community service activities. From a random sample of 100 students in the district, the administrator will construct a 99% confidence interval for the proportion of all students who participate in community service activities. Which of the following statements must be true? Right, so the population proportion will be in the confidence interval. Well, we know that's possible, but it's 100% certain. The probability that the confidence interval will include the population proportion is 0.99. That's pretty much correct. So, we can keep on going. It's gonna be B, but let me just gonna say why the other ones aren't correct. The probability that the confidence interval will include the sample proportion is 0.9. Nope. The confidence interval is created from the sample proportion, so it's gonna be guaranteed that it's gonna contain it. So that's it's nonsense. Part D, the population proportion and the sample proportion will be equal. No, that's not for sure. I mean, it could be, but probably not. Probability of the population proportion and the sample proportion will be equal. No, that's don't select those ones. So the answer is B. 27. 3 brands of candy pieces X, Y, and Z are made in many colors. Shayla, interesting name. 1 bag of each brand and counted the number of pieces of each color. The graph below shows the relative frequency distribution of colors for each bag. Okay, first let's pay attention to the word relative, because that's not essentially like the amount. It's percent. So remember, it's percent out of the total. So we don't know how many are actually in brand X or brand Y or brand C. They can have completely different totals. Brand X, they have like 1,000. brand Y could have 100, and you could have a million, and we don't know. So just make sure that's kind of I think what this problem's getting at. But these statements must be true. For brand X, there were more green candy pieces than red candy pieces in the bag. More green than red. Obviously not, because this is not even as much as that, so that's wrong. For brand Y, there were more red candy pieces than green candy pieces in the bag. Red is bigger than the green proportion, so that's correct. Keep on going, but this is what the problem is getting at. So there are more green candy pieces in the brand X bag than there were in the brand Z bag. So again, you may see that this is larger than this, but again, we don't know how many candies are in total. There could be 100 in brand X and maybe a 10,000 in brand Z. So even though this is a smaller proportion, it could be more raw total. So we don't know that for sure. And that's basically what the rest of it is. So remember, understand proportion is relative frequency. 28. A large city newspaper periodically reports the mean cost of dinner for typical restaurants in the city. The newspaper staff will collect data from a random sample of restaurants in the city and estimate the mean price of the merit. In past years, the standard deviation has always been very close to $35. Assuming that the population standard deviation is $35, which of the following is the minimum sample size needed to obtain a margin of error no more than $5? Okay, so let me just first kind of summarize how a confidence interval is constructed from a sample mean. I mean, you have your point estimate. We start with our sample mean, and from there we add and subtract the margin of error. So we add and subtract the critical value, to be Z star, times the standard deviation of the statistic. So the standard deviation of the population is $35. But let's look at our formula sheet. We look at our formula sheet. We have, we actually have all sorts of information. So make sure you get comfortable with this. It's going to be helpful. So what we're going to use is these values here. So it could be, you could say standard error technically, but in this case, it's the total population. Standard deviation is 35. We're going to have sigma. This will be what our margin of error will be, or this is going to be how we're going to make our margin of error. So the confidence interval is can be made as x bar plus minus the critical value Z star times standard deviation over the square root of the sample size. Remember, only this part is the margin of error. So the margin of error we want it to be no more than 5. So we're going to set this equal to 5. So we have to figure out the Z star for a 90% confidence interval. So 90% confidence interval, reviewing again. There's 90% in the middle. That means there's 5% to each side. So you can use your calculator and go to the inverse norm function. And all you're going to type is just the area to the left of it. So that's going to be 0.05. And that'll give you your Z star value, negative 1.64. This will be negative 1.64. It doesn't matter if that's negative, let's make it positive. Remember, it's symmetrical. This one will be 1.64. Now, standard deviation, we're told it's 35. And we're going to solve for n. So make sure you know your algebra. So what we're going to do is you're going to essentially multiply both sides by the square root of n and divide by 5. So we'll have the square root of n equals 1.64 times 35 in the numerator, all over 5. And to get n, we'll just square this whole quantity. So it's the 1.64 times 35 divided by 5. So that's the square root of n. Square that, and then n will be about 131.8. It's rounded, so we'll get about 133. That's our answer. Now I was like over a unit off because I probably just it's because of the z star. I didn't make this as accurate. So be careful. That doesn't throw you off. So I would be more precise. You just put like 1.644 or something. You would get closer to that. All right, 29. All right, field researcher who studies lions conjectured that the more time a cub spends playing, the sooner the cub will begin to hunt. Observational data were collected from 20 lion cubs. The researchers reported how long they spent playing and the age when they began hunting. Because male and female lions have different hunting behaviors, the researcher reported the data for males and females separately. 2 scatter plots show the data for the 10 female lions and the 10 male lions. All right, so based on these scatter plots, which gender does there appear to be more evidence that, or does there appear to be evidence that the more time a lion cub spends playing, the sooner they're more likely to begin hunting? So playtime, age of first hunt. So remember, like we want the age of first hunt to be low. So this is showing that as they have a higher playing time, the lower their age, the first hunt, it's trending towards that way. The male cubs, it's it's all over the place. It's not really a relationship. It would really just be A with say female cubs. All right, 95% confidence interval for the mean time in minutes for a volunteer fire company to respond to emergency incidents is between maybe 2.8 to 12.3. Which of the following is the best interpretation of the interval? 5% of the time for response is less than 2.8 minutes, or greater than 12.1. Sort of, but remember, it's just you're not sure. This is not a certainty. Right, it's kind of the right idea though, but that's still wrong. The probability is 0.95 that a randomly selected time for response will be between 2.8 and 12.3 minutes. Close, but again, not no, I guess. So remember, this is an interval that we're trying to this is an interval to estimate the population mean, not like a specific, not just any general like value, not just any general like incident. So it's not gonna be that. The confidence interval is to estimate the population mean. 95% of the time, the mean time for response is between 2.8 and 12.3 minutes. Again, no, it's not. Remember, this is just an estimate. We don't know this for sure. And again, this is not really. The mean time is like there is actual mean time. It's not like it's going to be sometime. Not like the mean is going to be sometimes in these values. There is a mean, and it's always going to be the mean. It's not like it's going to be not if the mean was 10. 100% of the time it's between 2.8 and 12.3. It's not like if the mean is 10 that sometimes it's going to be between these two values. That's wrong. D, we are 95% confident that the mean time for response is between 2.8 minutes and 12.3 minutes. So this will be correct. Remember, like we're taking an estimate for what the true main time is. We're about 95% certain that that's what it's going to be.